Hi everyone. This is one of the most easiest chapter in the subject. Okay, here you are going to learn about the different types of two-port network parameters. Okay, we all know what is a two-port network is, right? A two-port network means a network that has two ports. One port will act as the input, the other port will act as the output, and also vice versa. And also here we express V1 as the voltage across port 1, V2 is the voltage across port 2, I1 is the current through port 1, and I2 is the current through port 2. And the direction of I1 and I2 are going into the circuit. Okay, this network actually represents nothing but a interconnection of resistors, capacitors, and inductors. Okay, that's all. So there is nothing new to study here. Basically, all you need to understand are what are the various parameters, and then you need to learn how to express those parameters in terms of its equations and how to find those parameters. This is all you need to learn about this, and when you look at all these parameters, you will get a feeling that you have already studied this, because this is nothing but the application of mesh analysis and node analysis. That's all we are doing over here. So here this network parameters, what we are doing. So what is this network parameters? It's a bunch of equations, or it's a set of equations in which we can express each of these values over here, each of these variables in terms of any other two variables. That is the thing. For example, I can express V1 in terms of I2 and V2. I can express V1 in terms of I1 and I2. I can express V1 in terms of I1 and V2, and so on. For example, and I can express I1 in terms of V1 and I2. I can express I1 in terms of V1 and V2. I can express I1 in terms of I2 and V2. Same way, if you look in the case of V2, I can express V2 in terms of V1 and I1. I can express V2 in terms of I1 and I2, and I express V2 in terms of V1 and I2. And so on, which means I can express any one of these variables in terms of the other two variables. So on that basis, I get what you call as the bunch of network parameters. These are the network functions, and you can use any one of these parameters to describe your network. So basically, network parameter is nothing but a set of equations that is used to describe your network or to characterize your network. That's all. Okay, and so before we are going to move forward, so these are the various parameters, that is the open circuit impedance parameters, or also called as the Z parameters. Next you have is the short circuit admittance parameters, or also called as the Y parameters. Then you have is the transmission parameters, also called as the ABCD parameters. Then you have the hybrid parameters, also called as the H parameters. Okay, small letter H. Then you have is the inverse transmission parameters, also called as the A dash, B dash, C dash, D dash parameters. And then you have the inverse hybrid parameters, also called as the G parameters. It is called as the G parameters, or it's also called as the H dash parameters. Just like how you say A dash, B dash, C dash over here, we call this inverse hybrid parameters as H dash parameters. So these are the various parameters that you can use to express each of these equations, each of these variables in terms of the equations. So that is the one of the interesting thing about this chapter. You see, because if you can understand the meaning behind every term, if you can understand the meaning behind every name, if you can understand the meaning, then expressing those equations will also become very easy for you. And then once if you are able to express those equations, then finding the values of each of those parameters will also become very easy. And that's how they will ask the question. They'll give you a circuit and they'll ask you, find the Z parameter of this network, or find the ABCD parameter of this network, or find the Y parameters of this network. Okay, so currently in your syllabus they have asked only for the first four ones, that is the Z parameters, Y parameters, ABCD parameters, and hybrid parameters. These are the parameters that have been mentioned in the syllabus. These two parameters have not been mentioned in the syllabus, but anyway I will just express those equations. Okay, and let me tell you one more thing, that the method of finding these parameters, whichever parameters it is, the method of finding those values are very easy, because you are not going to do anything other than applying your very own the old mesh analysis and node analysis itself. You're not going to apply anything new over here. Everything is same like how you have studied before. The method of doing is exactly the same. All you need to do is, this time you just need to find the values of each of these parameters. That is what you need to do. Okay, so now before we are going to move to the parameters, okay, I'm going to discuss with you some two applications of these network parameters. You see, this network one of the important application of this network parameters is that you can use these parameters to find if a network is reciprocal or not. Okay, that is one condition. You can use the network parameters to find whether the network is reciprocal or not. And the another application is that you can use these network parameters to find if the network is symmetrical or not. See, so this is what you can use. This is one of the applications. You can test the conditions of reciprocity, or you can test whether the network is reciprocal or not by looking at the value of these network parameters. And also you can also check if the network is symmetrical or not by simply looking at the values of the network parameters. So before we are going to move into any one of these network parameters, let me first discuss with you what is reciprocity and what is symmetry. How to check for reciprocity and how to check for symmetrical. Okay, how to check if the network is reciprocal or not. To understand that, first let me tell you what is reciprocal network, how to check the condition of reciprocity. So let me write that is the condition of reciprocity. So what is reciprocity, or when does a network is to be reciprocal? Okay, you see, I will take a two-port network. Okay, I will take a two-port network, and this is port 1, this is port 2, so this is V1 and this is I1, this is V2 and this is I2. Okay, so first I will tell you what is the meaning of reciprocity. The meaning of reciprocity is that, you see, in this case, if I connect a voltage source over here. Okay, let me connect a voltage source over here, and this voltage source, the value of this voltage source is Vs. Let it be Vs. Let Vs be the voltage source at the port 1, and at the port 2, what I'm going to do is that I'm going to short it. Okay, I'm going to short these two ends. Shorten means then the value of V2 becomes 0, right? The V2 becomes 0 because both the end are now same, both the potential are the same, so therefore V2 is equal to 0. And the current through this short wire, I'm calling it as I2 dash. Okay, so in that case, this Vs, this source voltage Vs is called as the excitation, and this current through this end is called as the response. That is, this current is created due to the presence of this voltage. That is why this is called as the excitation and this is called as I2. Okay, and then what I'm going to do is I'm going to find the ratio of Vs by I2 dash. Okay, this is what I'm going to do is I'm going to find the equation of Vs by I2 dash. Next, what I'm going to do is I'm going to take that same port. Okay, I'm going to take the same port. I'm going to take the same network with the same two ports, and this time what I'm going to do is I'm going to connect the same voltage at port 2. I'm going to connect the same voltage at port 2. Okay, so now the voltage at port 2, or V2, is equal to Vs. And then what I'm going to do is I'm going to short the port 1, or I'm going to short circuit the port 1, or I'll just join the port 1. So therefore, let this current, the current through this short wire, let this current be called as I1 dash. Okay, so now in the second case, the excitation and the response has been reversed. The excitation and the response has been reversed now. So now this is the excitation and this is the response. Okay, so here what I'm going to do is I'm again going to find the ratio of Vs by I1 dash. Okay, so in the first case, what I'm going to do is I'm going to connect the voltage source over here, and then I'm going to short this over here to find the response. So this is the excitation, and so I take the ratio of excitation to the response, and over here what I'm going to do is I'm going to reverse the arrangement of the excitation and the response. Okay, I'm going to rearrange them, so therefore I'm going to reverse them. So this will be the excitation, this will be the response, then again I will take the ratio of the excitation to the response. And if the ratio of the excitation of one port to the response of one port is the same as the excitation, and is the same as the ratio of the excitation to the response of the other port, when both the ports are reversed, or when the excitation and the response are reversed, if those two ratios are same, then we say that the network is reciprocal. This is the meaning of reciprocal, or this is the condition of reciprocity. That is, a network is said to be reciprocal, okay, if the ratio of the excitation to the response is the same when the excitation and the response are being reversed. The ratio between the excitation and the response always remains the same. Such a network is called as the reciprocal network. So, like I've said, we can check the condition of reciprocity by simply looking at the various network parameters. You can find the conditions. So, for each of these network parameters, there are conditions of reciprocity which you need to find and you need to remember. Okay. So this is how they'll ask. For example, they'll ask you, find the Z parameters of this network and find if this network is, and check whether the network is reciprocal or not. That's how they'll ask. Okay. Now next condition. So this is one application of using the network parameters. The other application is to find whether the network is symmetrical or not, or the condition of symmetry. Okay, so what is the meaning of symmetry? Okay, now the meaning of symmetry is that, again, if I take a two-port network and which has two ports over here, and this is V1, this is I1, okay, and this is I2, and this is V2, okay, this is V2. Now the network, now how to check whether the network is symmetrical or not means, what I'm doing is that I will find the voltage to current ratio of one port. I will find the voltage of current ratio of one port by keeping the other port open. By keeping the other port open. Now, open means the value of the current at that port will become zero. That is basically the meaning of open, right? Open means no current can flow through. So therefore, no current will be able to flow through. If a branch is open, no current will be able to flow through. So therefore, the current to that branch will be zero. So here, if I say that port 2 is open, what I meant is that the value of I2 becomes zero. So in that case, I will find the ratio of voltage to current. Okay, the ratio of voltage to current. So now next what I'm going to do is that I'm going to take the same port. Okay, I'm going to take the same port with the same V1 and I1 and V2 and I2, and this time what I'm going to do is I'm going to find the ratio of V2 by I2. That is, I'm going to find the ratio of the second port keeping the first port open. The first port open means I1 is equal to 0. I1 is equal to 0. Okay, so here what I'm going to do, so basically what I'm doing is that I'm going to find the voltage to current ratio of one port, keeping of one port, and then I'm going to find the ratio of the voltage to current ratio of the other port, keeping, in both the cases I will be keeping the opposite ports as open. So in that case, if these two ratios are the same, that is, the voltage to current ratio of one port is the same as the voltage and current ratio of the second port, keeping the other ports open, then that condition is called as the condition of symmetry. Or if this condition is satisfied, then we say that the network is symmetrical. Then we say that the network is symmetrical. So this is how we find whether the network is reciprocal or not, and this is how we find whether the network is symmetrical or not. Okay, that is, we just check for both these conditions, and for each of these parameters there'll be different conditions of reciprocity and different conditions of symmetrical, which you need to derive and also which you need to remember, because always trying to derive for each of these parameters while doing the problems will be a time consuming process. So what I'm going to do is I'm going to explain each of these parameters first. Okay, I'm going to explain each of these parameters first one by one, and then I will tell you how to find the conditions of reciprocity and symmetry. Okay.